Hello, Precalculus. It has been a while, for sure. But welcome back. Couple things to talk about before I start giving you guys instruction. You need to check out Google Classroom 1. That's for sure. You got to do that. Two, make sure you guys know that the notes from this lesson right here that's attached in Google Classroom, get that right now so you have it close by in case you can't see something on the video. Three, I attached a video. I think it's Nancy Pye. She does a good job of just mapping out what limits are so that this video will make a whole lot more sense. You need to watch that video. I also put one on Khan Academy or from Khan Academy on there too to check out. Let's see here. Four. This is a very low tech video. All right, we're doing it in one take. So it's kind of like if you're in the classroom with me, I'm just going through the notes like I normally would do. Yes, it looks like a YouTube video straight out of 2008. Be gentle with me, okay? I'm very new at making these. So please email me your questions. I'm usually pretty available in the mornings and afternoons on weekdays. So just send me an email. I'll do my best to try to get back to you on that. And then lastly, the function composition chapter with like inverses and stuff that we did not really tidy up. Just put that on hold right now. I'm just trying to get you guys more exposure to concepts that will be helpful in classes beyond pre-calculus. So this first topic is actually like the first main chunk of calculus, all right? So we're kind of in calculus territory. Don't be intimidated by that. But I should be full disclosure with you on that one. All right, so the first thing I want to do is I actually want to skip A through D. I think that's actually the most complex part of this example, so I'm going to hold off on that. By the way, I might have to split this up into multiple videos just because I have a 15-minute max. So let's check out E through H for our first example. So we've got a function here. And hopefully what you picked up from the other video is that a limit represents what the function is approaching at a specific x value. For instance, if we're talking about E through H, and we're saying, what's the limit as x approaches the x value -2? Remember, limits are y values. They're the y value of what a function is approaching. So if we're talking -2, letter E says the limit as x approaches -2, and then this little negative up here means from the left. The little positive means from the right. So this function from the left is on my left index finger, from the right is on my right index finger. And this is kind of what's happening with the function. It's what's the y value that those are both approaching. Now, they can be two independent values of one another. They don't have to be the same thing. But in this particular case, from the left, the y value seems to be approaching -1. So, remember, x is -2. From the left, it's approaching -1. So letter E, that's -1. The limit as x approaches -2 from the right is also the y value -1. Okay? This little hole right here means there's not an actual y value occupying that spot. So when x approaches -2, the limit is basically saying, what is the function trying to become as a y value? The function is trying so hard to be -1 right there, but it never actually becomes -1. Okay? So it's really unfortunate for this function that it never did become -1, but it lives in its limit. So the limit as x approaches -2 is equal to -1. Now, f of -2, that's a different story. This is basically, if you go back to the function composition part of this pre-calc course, it was the last chapter, right? we were saying, what is the function when you plug in -2? So for this function, when you plug in x equals -2, what is the filled in y value that actually represents where the function is behaving at the spot? So if you do a scan of x equals -2, that hole does not represent a value. That hole is basically a space that is unoccupied by this function. And as you keep moving downward, you find that it doesn't equal it anywhere. So when x equals -2, y, it doesn't live there. Y is, I call it undefined. I've seen it talked about like that in several textbooks. I think in the video, she called it indeterminate, which is another great way to describe it. If we could be on the same page, though, that just use undefined or indeterminate, okay? Don't put weird answers like no. I've seen that before, so just throwing that out there. Okay, so, pause that, go back earlier in the video, see the explanation again, but it should be -1, -1, -1, and undefined for that first part. Let's check out a different situation. What happens when they both seem to be converging to the same spot, but then there's a random dot somewhere else? What is that supposed to mean? Well, this is the x equals 1 value right here. And if you're coming from the left, as it indicates on letter I, coming from the left of x equals -1 should yield that you're moving up 1, 2, 3 y units, okay? So it's up 3 when you approach x equals 1 from the left. Now, that's not what the function is trying to approach, okay? The function is trying to approach this from the left, okay? So it can get kind of tricky there, but the behavior of the function is it's on the path to 1. So that's what we're going to do. I'm sorry. It's on the path to 3, the y value. So when x approaches y from the left, x from the left, y equals 3. Sorry, my words are not coming out right. From the right, okay? So this part of the curve is representing the function as x approaches 1 from the right. It also ends up at y equals 3. The approach ends up at y equals 3. This dot up here represents sort of that's where the function actually lives in that spot. I think of it kind of like, I've coached running in the past, yeah? And a lot of times, this is maybe where the training is headed, but then the performance is actually, whoa, you exceeded the performance way out of there. Or in other cases, you could really not exceed the performance and do poorly. So I don't know, if you want to try to piece together metaphors in real life, this would be this is where your training is pointing you towards. That was your actual performance. In this case, yes, it was awesome. So instead of a 3, you got a 5, which is actually the f of 1 value. That's where the function lives. F of 1. I totally skipped over x approaches 1. X approaches 1 at 3, right? So if it matches from the left and the right, the limit as x approaches 1 is 3. So hopefully this isn't too confusing so far. My apologies. Again, email me with questions. So let's check out 4, the x value 4. All right, so 1, 2, 3, 4. When we look at that, it seems like we've got a weird situation where these curves are forever getting closer and closer to this line, but never actually crossing. If you remember from the graphing sense chapter, we had vertical asymptotes. That's what I was getting after here. So, what happens when we have a vertical asymptote? Well, if we think about it, think about it with the metaphor of maybe we've got somebody driving a car along this function, and they're trying to meet from the left the car that's coming from the right-hand side of the function. The limit is the spot where they're trying to meet. So here, we're driving along, we're driving along, we're driving along. We're getting closer and closer and closer to the 4 value for x, but we're never actually going to get there. So like when we're getting closer to like 3.999, that's really close to 4 from the left. You're going to have a huge number because this function from the left just keeps getting taller and taller and taller, higher up on the y-axis. So how do we describe it when it seems like you're getting ever closer to the y-axis? I'm sorry. You're getting ever closer to x equals 4, but you never actually cross. Well, you keep getting larger and larger as an amount. You get astronomically larger. You get infinitely larger. So you're just going to say that from the left, it's positive infinity. From the right, the same thing's happening. You're getting closer and closer and closer and closer to that asymptote, and you're never going to cross it. So, your value is astronomically bigger as well. So we're going to say that you're positive infinity. Now this is the tricky part. What is the limit at x equals 4? Well, before it was sort of like, this is the spot where we're converging towards. This is the spot that we're converging towards. And it was always, if the limit from the left matched the limit from the right, then that's the answer for the limit at that spot. If the limit from the left matches the limit from the right, then that's that at that spot. So it stands to reason that your answer should just be positive infinity, right? That's actually not correct in this case. Here's the reason why. The limit represents a finite value, okay, that actually describes where the 2 points are trying to meet at. So it's kind of like these two cars, if they're going to try to get closer to each other, it's sort of like, let's say that this represents like a body of water that cannot be crossed by a car. These cars just keep driving forever. They're driving forever. They're driving forever. They're never actually crossing that body of water, that river, whatever you want to call it. So where do they converge to? They don't converge to one another at any y value. So this is where we say that the limit actually does not exist in this situation. The limit does not exist at x equals 4 because the left and right do not converge to a specific value. So, limit does not exist. And you know what? You can put a DNE for that situation. I'll know it means does not exist. Now, I want to say this. It's different from a function, okay? I want us to use the terminology that the function is either defined at a specific point or it is undefined. A limit either exists at a certain point or it doesn't exist. I might just be picky with semantics, word choice on that, but let's try not to describe this situation as does not exist. Thank you. All right, so f of 4, great situation. I just talked about it. So f of 4, this is an invisible boundary. There's no actual place where that function exists on that invisible boundary. So it's kind of like an open circle type situation. There is no y value that can be accounted for x equals 4. So when x equals 4, y is undefined. All right, I am going to stop this filming because after 15 minutes, I can't post any videos beyond 15 minutes. So I'm gonna hop back on here and finish this example. So I'll see you in like 5 seconds.